Hello students, welcome everyone to bonus gate classes for ECE. So in this video, let us talk about intrinsic semiconductors. Okay, generally silicon and germanium, whenever in its purest form, can be used as an intrinsic semiconductor. That means there will be no other impurities has been added. Okay, for to change their electrical properties. Hello everyone, welcome to bonus gate classes for ECE. So in this video, let us have a talk about intrinsic semiconductors. Okay, so generally intrinsic semiconductors are purest form of silicon and germanium are taken. Okay, without adding any other elements as impurities. Okay, in this condition, so whatever the number of free electrons will be created, same number of holes will be created in the valency band. Okay, and the same number of free electrons will be there in the conduction energy band level, so that both holes and electrons will support the flow of current. Okay, here the magnitude of current flown by the free electrons will be more than the magnitude of current produced due to the holes. Okay, because the mobility of electrons is more than the mobility of holes. Now another point is, whenever if you increase the temperature, okay, at 0 Kelvin, the same intrinsic semiconductor will act as an insulator, because there will be no free amount of free electrons will be there. So as the temperature increases, those electrons will gain the energy and will enter into the conduction energy level. Okay, hello everyone, welcome to bonus gate classes for ECE. So in this short video, let's see intrinsic semiconductors. Okay, generally silicon and germanium, the elements whenever used in its purest form, that is without adding any extra impurities, so they will be considered as intrinsic semiconductor. Okay, so in this type of semiconductors, number of holes that will be generated in the conduction band will be equal to the number of electrons that will be there in the valence energy band. Okay, that means here the charge carriers are electrons and holes. So due to this both electrons and holes, current will be produced. Okay, but the magnitude of current will differs, because the electrons mobility is more than the hole mobility. So the electron produced in the conduction band level, okay, will be more than the current produced due to the holes in the valency band. Okay, and that point is, as the temperature increases, the conductivity of this semiconductor will increases. So if you take the same semiconductor at 0 Kelvin, it will act as an insulator, because there will be no free electrons in the conduction energy level, so that amount of current will be 0. Okay, so as the temperature increases, amount of current, the free electrons will get excited to the higher energy levels. So if they reach into the conduction energy level, so they will support the flow of current. Okay, so here the point is, as the temperature increases, the semiconductor conductivity will increases. Okay, so there will be so many topics will be there, will be seen later. Thank you very much.